Hello and welcome. Today's video lecture will focus on production functions. Let's begin to understand production functions through a problem. Part A of this problem reads, consider a firm that has the following production function. Q equals 4 times k to the power of 0.7 times L to the power of 0.3. Calculate the total amount of production if the firm has 20 units of K and 10 units of L. First, let's understand what these terms mean. So Q is the amount of production, K is the amount of capital, and L is the amount of labor. So this production function is a function that takes two inputs, capital and labor. Those two inputs will produce a certain amount of production. So for this part of the problem, we are told the firm has 20 units of K, capital, and 10 units of L, labor. So to find the amount of production, we will simply take our production function and substitute 20 for K and 10 for L. When we do so, we get an answer of 64.98. So when this firm operates with 20 units of capital and 10 units of labor, they're able to produce 64.98 units of output. Next, we move to Part B. Part B states, calculate the total amount of production, the average production of labor, and the marginal product of labor as the firm moves from 10 units to 15 units of labor, keeping capital constant at 20 units. So before answering this question, we are going to define some terms. First, let's define marginal product of labor. By definition, it is the amount of quantity, the additional quantity, one laborer or worker brings in. Mathematically, the marginal product of labor is equal to the derivative of quantity with respect to labor. Next, let's look at the average product of labor. It is the average amount of product or quantity a group of workers or each worker in a group brings in. So mathematically, the average product of labor is defined as quantity divided by labor. Also, pardon this misspelling here. To help organize ourselves, we are going to use a chart formation to solve this problem. We are told that capital will be constant at 20 units throughout the duration of this problem. We are also told labor starts at 10 and goes to 15 by increments of 1. And we know that our beginning quantity is close to 65 units. Our first step in solving this problem will be to fill in quantity at every position. To find quantity, we will use our quantity equation that ties together capital and labor. At the first instance, we know capital is 20 and labor is 11. To find the quantity produced, we simply plug in 20 for K and 11 for L, and we get this amount of quantity. We will repeat the same thing when labor is 12. Again, we substitute 12 for L, keep capital constant, and we get a quantity of 68. Again, we repeat this when L is 13, repeat again when L is 14 and 15. Now we have solved the quantity at every position when labor increments from 10 to 15. Here we have our quantity positions filled into our chart. Next, we move to solve for the marginal product of labor. Okay, so mathematically, the marginal product of labor is defined as the derivative of quantity with respect to labor. So our first step in solving for MPL is to find the derivative of quantity with respect to labor. So here's our quantity equation. Let's take the derivative. To take the derivative with respect to labor, I look at the labor portion of this equation, take that exponent and multiply it by 4, and subtract the exponent by 1 as stated by the exponent rule. So after applying the product and exponent rule, we get a derivative of 1.2 k to the 0.7 and L to the negative 0.7. So now we could use this formula to find MPL. So in the first case, we know capital is 20 and L is 11. So to find the marginal product of labor, I simply plug in 20 to the K position of the derivative and 11 to the L position of the derivative. Here I have the values plugged in. After doing so, you calculate a marginal product of labor of 1.88. So let's interpret this. What does this mean? This means that the 11th worker you hire will bring you an additional 1.88 units of product. Let's repeat this process when L is 12. Again, we use the same derivative equation, but instead of having L at 11, we plug in 12 for L. After the values are plugged in, we evaluate MPL to be 1.77. The interpretation is as follows. The 12th worker you hire will bring in 1.77 units of product. You repeat this when L is 13, plug the values into the derivative, and get 1.67. The 13th worker brings in an additional 1.67 units of product. We repeat when L is 14, and we evaluate MPL to be 1.58. The 14th worker brings in an additional 1.58 units of product. We do this again at 15, plug the values into the derivative, and get a marginal product of labor of 1.5. The 15th worker brings in an additional 1.5 units of product. We have now found the marginal product of labor at each position and filled it into our chart. Our next step will be to find the average product of labor. If you recall, mathematically, the average product of labor is given by quantity divided by labor. So let's find APL at each position. So when we have 11 workers, we previously found out that the total amount of production is 66.86. To find the average product of labor, we take the quantity and divide it by the labor, and we get 6.08. Let's interpret this. When there are 11 workers, each worker on average produces 6.08 units of product. In the next case, when L is 12, total production is 68.63. Plugging these values into our formula, we get an APL of 5.72. And this is the interpretation. When there are 12 workers, each worker on average produces 5.72 units of production. When L is 13, 70.38 units of quantity are produced. Solving for APL, we get 5.41. This is the interpretation. When there are 13 workers, each worker on average produces 5.41 units of production. Next, when L is 14, we solved quantity to be 71.88. Solving for APL, we get 5.13. Here's the interpretation. When there are 14 workers, each worker on average produces 5.13 units of production. Last, when L is 15, we have a total quantity of 73.39. Solving for APL, we get 4.89. When there are 15 workers, each worker on average produces 4.89 units of product. Here we have filled in APL at every position, and this section of the problem has been completed. Let's move to the next part. This section asks, does the firm have decreasing, constant, or increasing returns to scale? How do you know? Before answering this question, let's look at some definitions. What are returns to scale? Returns to scale measure how a quantity changes when inputs change. For example, if we have increasing returns, changing inputs by one factor will result in a quantity change that has shifted by more than one factor. In other words, if you increase the factors labor and capital by a value x, quantity will increase by more than the value x. Let's look at decreasing returns. Here's what they look like. If you increase the factors labor and capital by a value x, quantity will increase by less than the value x. And lastly, constant returns. If you increase labor and capital by a factor x, quantity will increase exactly by that factor x. Now let's go back to this question. We have to figure out if the firm has decreasing, constant, or increasing returns to scale. So to find this out, we have to multiply inputs by a factor. So in this case, we'll say the factor x is 2. Previously, we had labor at 10, capital at 20, and a quantity of 64.98. So what I will do here is I will multiply labor by the factor of 2, capital by the factor of 2, and see how much quantity I end up with. If I end up with this amount of quantity times 2, I have constant returns. If the quantity more than doubles, I have increasing returns, and if the quantity less than doubles, I have decreasing returns. So let's apply the factor. Multiplying labor by 2, I get 20, capital by 2, I get 40, and I plug these back into the original quantity equation, and I get a quantity of 129. Notice 129.96 is exactly double the original quantity. So when we applied a factor to both labor and capital, quantity increased by the same exact factor. So in this case, we have constant returns to scale. And that is all for this tutorial. Thank you for watching.